Record. Good morning, everyone. It is 5th of March, and I'm joined by a very distinguished guest, Nick and Rahat. It's always pleasure with them to talk about and challenge our mindset on different things. As you know, Nick is the guru on IoT side of things. His various talks and various architecture design has been a great advantage and shared well across. So we were getting a lot of questions, and Rahat pointed out that, hey, bro, we are getting so many questions on IoT. Everyone is saying if we are IT engineer, how could we, look over from that perspective, because we don't know about hardwares, we don't know about electronic or electronic side of it. Do we need to know? And thank you so much, Rahat, to pointing in that direction. That's why we get you the best guy, and welcome again on the Canadian MEP show. Over to you, Rahat.
Hey, thank you for inviting us. It's always fun to talk at this weekend morning show actually. And today, as you said, we got a lot of information about IoTs. How can we apply AI on IoT? What type of security measure we need to consider within the cloud platform? So that's why we found this pretty complete use case actually. And this document is available in the Microsoft section where it's covering the IoT side, which will be covered by Nick. It's also covering the data processing and AI, which I will cover it. And there is also security deployment and high availability along with disaster recovery, which is from the cloud side within Azure, which Deepak is going to cover. So it will be an interesting talk, which is going to cover almost 360-degree view of IoT, data analytics, AI, and cloud.
So Nick, over to you. What do you think about, my friend? I know you are the guy in 2017 to one of the Western power client. You have implemented the preventive maintenance solution. You visited to that province, I know, Saskatchewan, and you really promised at that time, okay, it is really great province. So what is your understanding over there on the IoT side of thing? If you help us to understand, because it's very new for us.
Okay, so I'm just generalizing. So on the IoT side, well, when you use the word IoT, we're talking about on-prem to cloud, that section. Basically, the team has kind of divided into two sections: software engineers, which basically they spin up services in the cloud, IoT, and so on. And there's an electronical engineer or an electronical background. So these are the people who know how the devices, the very CPUs and how the device is generating data, or the manufacturer who created that device. So you have to know which side you're on, but bottom line is that the goal is to bring the data from an on-prem environment to the cloud. That's the biggest goal and you need. So what are these? I'm just going to go very high level. What are the layers on the IoT side that you really need to know and understand? You have to understand how these devices generate data and what kind of data they generate. And sometimes what is missing in that data. For example, there are devices that generate full breadth of everything, but they don't generate their own name. It happens. It could be the old device. It could be, they could have other reasons. They could have a tagging system. But anyway, there are techniques and tricks to basically bring that name into the IoT so you can pass it on to the cold path and warm path, which Rahul will be speaking. So I'm just generalizing what is need to be done. It's about your devices, what kind of data they're generating. You have to talk to the manufacturer, make sure specifically, because if a device is generating an alert, like a alert as in fire, the place is on fire, you have to know this data is a very critical data that you need to send a notification. So notification, you need event grid. So event grid is within IoT Hub. You can set it up. So if a flag, let's call it flag red or flag fire, basically come through IoT. You can set it up using event grid and other services to basically send an email. I just want to keep it simple. I don't want to boil the ocean for this. that's one of the things you have to know. So the notification, I'm just reading it from somewhere else. Notification is very critical. Where you're routing the data. So there's two important parts. It's cold path and hot path, which Rahul will take over and explain. And the device, and there's something called device provisioning. So when I'll give you two examples. When you buy a router from a company, a telecommunication company, when you plug it in for the first time, you have to wait 5-10 minutes. Why? Because it's trying to introduce itself and your IP address and some other factors behind the scene, and it downloads. So guess what? IoT is a two-way system. It talks on both sides. It instructs the devices to do something, for example, install a software, and sometimes it's the other way around. It just gets information, which is called telemetry data, and passes it on to the cloud. So device provisioning, this router is a good example. And sometimes let's imagine the ship, real ships that you take, like Disney ships and things like that. So when they're docking basically through Wi-Fi, they're connected to a local IoT. So it is basically pushing the data to the cloud. But when it goes in the middle of the sea, and let's assume it doesn't have internet connection, well, it saves its data where? It saves it on an IoT edge device. If someone says, Nick, what is an IoT edge device? I would say, in a simple English, I would say it's an on-prem server machine that will contain all the data, and basically down the road, depends on the connectivity. The ship is a good example. Down the road, when it connects to a proper Wi-Fi or to the right docking mechanism, it will pass on the data to the IoT hub, and IoT will push it up to the cloud. I can just mention a couple of things. Is notification. We talked about message routing and built-in endpoint. So this is where it splits the data into hot, cold, with the right messages or custom messages that you may want to add on top of the telemetry data that's coming in. Correct. So I think after this, Rahul can take over completely.
Yeah, but we will not let you go from here, Nick. So I know when we were working on Western Power Client, there were a couple of challenges we encountered. We encountered a couple of firewalls were blocking the data transmission. Second challenge we experienced about, different type of data, the huge amount of data which was generating, and we have to, process that data. Processing is not a problem. Rahat is the best guy who could, put light over there. But one was that challenge, and another challenge was related to how to, understand that data. I know, Nick, you have done a couple of videos where fortunately I was part of that, where we did a IoT device change voice mechanism we did for pharmaceutical industry as well. So basically, would you help to understand, like, if someone want to know, okay, Nick, I need to do ingestion, would I use IoT Hub? Would I use IoT Central or IoT Edge? How these devices are, different handshaking between on-prem to cloud happen, how they are different?
Well, as I said, the edge is basically a local computer. I'm just, again, explain this very simple way. There are a variety of edges that you can have to go and see in the market. So they look very small, but there are basically devices that they can connect to an IoT gateway or basically the IoT itself. That is different than an IoT. An IoT is basically in the cloud. So it's not a physical device that you have. An edge is a physical device that you have on-prem. Let's say a production manufacturing line. So when you buy a production manufacturing line, pharmaceutical is a good example, right? The company who's assembling, basically, they have a computer that measures the speed, the temperature, because they have to measure these temperatures to see if they're putting too much heat on these pills. Let's say they're manufacturing pills. So they have to keep this. Where do they keep it? They keep it on an edge. Now the question is, do they need to push that in the cloud for extra processing like machine learning and cold path and things like that? So this is where you can differentiate them. Some of the devices do not need to be connected directly to the cloud. They're connected to the edge, and the edge is doing the magic for them. So you don't need the full breadth of everything from on-prem to the cloud. And if you do, the question is, which one is more valuable? Okay. For example, let's say I have a temperature of a room. It might not be much of a valuable enough compared to a, let's say in that room, you have an engine that is running. I want to make sure that engine is working, not the room. I don't care about the room because I know it's located, let's say in an area that's the average is between 20 and 30. Let's say, I don't know, I'm just throwing an example. Let's say Vancouver, Florida. Well, Florida is way hot, way warmer. North Carolina might be a good example. It's not too cold, it's not too hot. So I don't care about the room temperature. It's not very critical. But bottom line, I think the most important thing is before you make these decisions is you have to have an inventory of your devices. You have to have an inventory of the messages that they're generating. And before you do any kind of architecting design, my suggestion is make sure you run KQL on their sample data, understand what they have before you even start designing or doing anything. That's the most critical thing from my opinion.
That's so great. Thank you so much, Nick. It's so valuable. I feel, my concept is always polished whenever I talk about, IoT with you. So Rahat, this kind of things, is for so many folks, which we receive the message as well. Specifically, they need to know about data transformation, what the heck is warm path or cold path, those kind of things. Would you help me to understand and what it is and how someone can plan in their architectural model?
Yeah, I will divide the entire section into two different parts here. One is the data handling, another one is AI. So on the data handling side, as Nick was saying, that from the edge devices, you're getting the data. Okay, you can have 5 values, you can even have 50 values. Sometimes you get real-time data, sometimes you get a big dump of all the values in full resolution as a late data arrival situation. So the way we see it in the when we work with the IoT world for AI and everything, the data that is coming always in the real time. So usually those real time data are low resolution because of data transfer issues, and also we don't need all the parameters in real time to say engine is working well or a truck is moving or aircraft is moving, something like that. All you need to know that first, very crucial 5 or 6 parameters: the location information, the speed, or any kind of DTC score, or if there is an engine issue or not, something like that, 5 or 6. So those values that we bring that are always critical, we usually pass them through the warm path store or warm path zone, so that from a business application point of view, if you have a web application or something like that, you see it in a real-time application where are all your cars are, aircrafts are, or your trucks are, or something like that. So things that you need to know for a business decision, you just get that type of information. Now, your IoT is not collecting those 5 values. Your IoT maybe is collecting 50 to 200 values. So in that case, and also in full resolution. When you apply AI, you need more resolution because you need to train the algorithm. You need to find out all those small patterns. In that case, maybe instead of sending real-time values based on the internet connection, network, and everything, every 2 hours, 5 hours, once a day, you can do a full data dump. And all those 100 variables that we're talking, they don't need to come always, as I say. They will come later so that you can do analytical decision making. How is this entire truck performing, or this aircraft performing, where this engine is impacted and giving you less MPG or something like that. So for that type of analytical decision making, you bring those big flow of data. You can pass them to cold path so that your machine learning is close to that cold path and find out different types of pattern analytics or something like that. So 2 things here. The first learning is you need to always keep your operational activities and your analytical activities separate. You should not keep them together. Then the data transformation side, it also depends. It varies from company to company. Sometimes you do the real time is always real time. Obviously, you need information, but for a analytical point of view, you do segment wise calculation or hourly hourly calculation, or even daily calculation. So in that case, when you bring all the data, you don't need to keep every single record, because if your IoT device is sending one record per second, in that case, there is like 3,600 of like values in an hour or something like that. So you don't need all those values to take a analytical decision making. You can do day-wise segmentation, where you will load all the data, you will summarize all those data, so that you have the insight from this data and keep only the insight. Like it can be one full detailed record per day, per truck, per aircraft, or per car, or per engine, or something like that, so that it's easier to connect a Power BI or something like that and see different types of like trends on that. So this is the data side. And when you're transforming the data, you need to have the data transformation into the right segment, right summary of time frame, considering the right format as well, can be per K or something like that, avoiding CSV because those are bulky size. So that kind of situation, and also storing them into the uh, proper hierarchy of data storage. It's like it can be company one, year 2023, January 5th, something like that, so that you can find those data and you can run those type of analytics on a daily basis. For the AI, we see it also like two or three types of mechanism. In Azure Machine Learning, you can use your like connect your data store and then try different types of like AI algorithm. But Azure Machine Learning is also like mostly designed in a way where you use it for real-time processing. So when you're training the model, you take the model, deploy it in a single container. We call it ACI, Azure Container Instance, and then test it as a API call or something like that. You send a JSON with the API information and header to the container, and the container send you as a response, okay, this engine is about to fail or something like that. But when you are deploying it on a lots of like pods, because suppose every second you get 10 requests from your applications, but from the AML side, it takes 1 second to do one prediction. So in that case, you will need at least 10 to 15 pods, so that your application is always up and running, and also like you're maintaining proper like queuing mechanism. It's not like waiting a lot of time, something like that. So in that case, you can use AKS as a Kubernetes service, where you can deploy that ACI container into like a 10 different or 15 different replicas. You can always say to when to spin up, when to spin down, something like that, so that you're maintaining that scalability. But one other thing we also see in the IoT world, as you don't need to do those real-time inferencing, you usually do once a day batch prediction or once a week batch prediction, because IoT doesn't show that type of like values unless it's just like yes or no, that kind of things in real time. So in that case, you can use Azure Machine Learning. Azure Machine Learning has option for cluster-based inferencing, but if you want to like reduce the cost, you can always introduce ADX, Azure Data Explorer, where when you're bringing the data, most of the data are time series based. You can always like process the data, the time series based data, and then pass it through ADX like a KQL. KQL can also like load a Python, a PKL file, pass it through an AI model, and then prepare those prediction and store those prediction on a weekly basis or something like that, so that you can do batch inferencing, and it's going to like reduce your cost significantly. Same thing, you can also use Databricks or Synapse-based Spark notebook, where your model is already trained. You pass it through like a batch processing of like millions of rows, have the predicted values 0, 1, or something like that for multi-class classifier, and then store them into your like ADX table or something like that. So that's how we see it. To where you, if it is a real time, you can use Azure ML, ACI, and AKS. If it is some more into like batch processing on a daily basis or weekly basis, you can either use ADX or you can use Spark-based notebooks.
That's so incredible, Rahat. So the way you move from one component to another, one service to another service, it is quite visualizing. And that's why everyone want to attend this our morning show, because here we don't go about presentation, we don't share about some documented things, we go about real-time scenario. And that is what we want to discuss today as well, on security and disaster recovery. So let's start from very basic. And if I have to start with very basic, I would say, okay, there are some, best practices for which we need to follow for, Azure, and those best practice are: first and foremost, Azure Security Center. Please pay the attention over there. The security score make you secure. You can consider security score as your credit score as well. So more credit score, more you are financially secure as well. From that perspective, so more score. That's why they put the number over there. So, and if I have to put into term of the IoT devices, I will always also consider another example where you need to update your IoT devices up to date and secure. Security enhancement communication is so important, so that you are sending and receiving and both are secure. Second, piggy bank suggestion would be you could keep your IoT devices up to date and secure. Third, the suggestion which we have implemented so many solution, full integration with Azure Event Grid and serverless computing. That is always recommended, and compatibility of IoT edge and different IoT application. Always look for from different solution. The solution which you are implementing, or IoT solution which you are implementing, are they are upgraded? Are they are still on stone ages? All those kind of questions you need to ask from yourself. So let me share one customer example. So customer want to remain competitive, and we implemented that solution. Me and Nick implemented that solution. Customer want to be competitive into new data driven market. The customer has siloed and aging data infrastructure that make it difficult to take the decision for high view of company operation and work efficiency. That's what we need to do. What solution we have recommended? We recommended the solution digital transformation on Azure, and we integrate and migrated data center with infrastructure to go into a single cloud solution. And that single cloud solution for us was the Azure. What impact we could see? It enhanced the cyber security, raised security score by 30%, which I mentioned, I don't know, in last talk over here or somewhere else. When I was working with, school division / Ministry of Education, we were compiled with secure score. Or like we could not check in the code which decrease our score, up to certain level. So security score increased by 30%. We accelerated the database refresh process significantly, and we decommission in that case 75% of server. So this industry, the product which we have used, Azure SQL Server on Azure, Microsoft 365. So that integration is always important. There was a SharePoint as well. We make it convert into online SharePoint and OneDrives and Azure Active Directory and Azure IoT Hub. Here, I'm not touch basing about those things. Okay, make multiple factor authentication, give the conditional access, for example. But if I have to touch base for another 4 minutes, so let's start from basic. Always look over your secure score. Always go to security, your Azure, and look over what is my secure score is. And that is so important. You need to go to Azure Security Center and look from that perspective, what is my score is. You always pay attention to your advisor recommendation and security. You can look for what is, security, kind of 100% compliance over there, and so many things. I'm not going to Microsoft Defender or Azure Lighthouse, all those kind of details where we could have security posters, that is well taken care of. It adhere to all those protocol where US go to GDPR for Europe and different clients and different customer. For example, in Canada, we are adhere to the government regulation for Ministry of Education, because we are dealing with very sensitive workload over there. So it has my 100% secure score and all those kind of things. So basically, for sometime for demo, we open the recommendation. So that is what we require. So I think I able to explain. Always pay attention to your Azure Security Center. Your secure device, IoT device should be updated. The two-way communication should be set up, and software should be, adhere to the different practices as per different countries and their policies. The conditional access should be there. If you want to ramp up someone for 2 days, you should provide the conditional access. There should be multiple factor authentication, so you should know, and always look over from that perspective. So folks, that's how this show, we run, and this show we look for that perspective. And today we discuss about security and disaster recovery. It's not those time when me and Nick started our career. Rahat is too young. We could adopt him as well. So, but at that time, it was disaster recovery. We have to implement on specifically hardware device and two-way communication and all those things. So we cover each and every component over here. But if you have questions, which you mentioned last time as well, drop the message. We will touch base that. We have champion on IoT space. We have Rahat from AI, and I just plug and play whatever is, on Azure cloud is required. Nick, I know you want to say something, so over to you. You are mute though.
Yeah, just something came to my mind. It's from a client. I cannot say the name, sorry about that, but it was something interesting. What we were all talking about, we talked about ADS, cost, Databricks, Spark. So these are brilliant tools, especially ADX, one of the best tools I've worked with. But the question is, do we need all of this? So I'll give you a story about a client. They were using SQL Server, Azure SQL Server as a warm path. And I was just like, in the IoT field, I was just like, that's not a good approach. That's, I couldn't say anything to it, but they gave me the most convincing reason that I said, oh, they have the best approach. And you know what? They only had one 100 megabyte per year of data. I'm like, okay, you're dealing with peanuts.
Yeah, so, then fine. Yeah,
yeah,
for sure.
So what I'm trying to say is that the amount of data that they were working with, their data was sensitive. I can't say the company, it's a very, very famous company. Everyone has one of their product at home. But I told them, why did you do that? And they said, this is the amount of data. So what I'm trying to tell you is measure what you need. So sometimes you don't need to boil the ocean. Sometimes you could do it dirt simple and dirt cheap. So that's where the customer becomes happy. So that was something I was very surprised in the beginning, and I loved the solution. But again, that was the proper thing. They measured everything. So in the IoT, measure before you spin up any services. Trust me, it will work perfectly.
Yeah, at Isaac, so we use ADX and other tools. One of the reason is we collect 220 terabyte of data a year.
Yeah,
that is a massive, and it's impossible. Even our SQL Server is 5 to 10 terabyte. So we are trying to bring it down. Like lots of databases are 500 plus clients, so it's spread. So, but again, one of the main reason of using ADX and moving on that side so that we have less pressure on the SQL Server.
Yeah, perfect.
So your business problem is really challenging, and I know I have the best two faces who could resolve those business problem. One is already there, and on IoT space we have Nick. But it's so interesting, and thank you so much, folks. I know we are just being cognizant of time. We are closing it soon. So it's 5th of March today and at 10:50 a.m. for us, and we will see you next week. And last closing comment, Rahat and Nick.
I think we should give people one question for them to Google, maybe, something like that might be interesting.
Yeah, go for this.
In the hot path, what is TTL, time to live. Let them Google it. It'll open up their mind. They'll have a different perspective. So
great. That's so amazing. Rahat, bro. So
from my side, nothing much. Like just do your whoever is listening, do your quick search about those tools that we mentioned: Azure Data Explorer, KQL, Azure ML, ACI, AKS. So you will get your idea how the data is coming, what you're going to do with that data. Yeah.
that sounds good. Thank you so much, folks. Have a good one. Enjoy your weekend. And we are going to play the games today. Have a great one. Take care.
you too. Thanks a lot.